Good morning, sir. Good afternoon, sir. SP Datta, sir.
Good afternoon.
Your brother बोल रहा हूँ, sir.
How are you?
Fine, sir. আপনি কেমন আছেন?
ভালো আছি।
আচ্ছা। দ্বিবেদী স্যার কেমন আছেন এখন?
দ্বিবেদী স্যার বেশি ভালো নেই।
এই তো আরএসি মিটিং অ্যাটেন্ড করলো 7 তারিখে আমাদের।
হ্যাঁ, দ্বিবেদী স্যারের অনেক কষ্ট হচ্ছে ওই এর জন্য, কোভিড এর জন্য।
ওই দিন অনেকটা ব্রিদিং প্রবলেম হচ্ছিল, মিটিং এ অ্যাটেন্ড করেছিল স্যার 1 ঘন্টার জন্য।
হ্যাঁ। কষ্ট হচ্ছে ওনার।
আচ্ছা, স্যার তো অফিসে আসছে না নাকি?
অফিসে আস
হ্যালো।
I think in the connection টা কেটে গেছে।
হ্যাঁ, অফিসে আসছে তো। আর আপনাদের ডিপার্টমেন্টের ক্লাস সব অনলাইনে চলছে তো এখন নাকি?
হ্যাঁ, অনলাইনে চলছে।
শুনলাম নাকি আবার দেবাশিস দা বলছিল ফিজিক্যাল ক্লাস শুরু হবে।
না, এখনো ডিসাইড করিনি, ওটা ইউজিসি বলবে।
ওকে।
হ্যাঁ, ইউজিসি বললে তবে।
আচ্ছা।
Good afternoon, sir. Myself, Dr. Abhas Kumar Sinha from the Department of Soil Science, Uttarbango Krishi Vishwavidyalaya, sir. So, hearty welcome, sir. Please, we are very pleased that you have joined this session and you have given us opportunity to listen to your lectures, sir. So, in this webinar, it has been started on 5th of this month.
Hello.
Sir, am I audible?
Oh, not just. Hello.
Sir,
Yeah.
am I audible?
Yes. Now you are audible.
Okay, sir. Myself, Dr. Abhas Kumar Sinha from the Department of Soil Science, Agriculture, Chemistry, Uttarbango Krishi Vishwavidyalaya, sir. So, sir, we are very pleased that you have joined this webinar on our request. So, today in this webinar, we have started in the morning. So, we had Dr. Ranjan Bhattacharya, then Dr. Mahesh Ghatala, and the last session is yours, sir. So, today in this webinar, we have Professor Dibyendu Mukhopadhyay, who is also our Dean Faculty Agriculture and presently our HOD Soil Science. So, and also Dr. Shatra is there from Kazri, and we have students and also faculty members. So, sir, this webinar we have divided into 5 parts, or rather 5 broader fields. So today we had conservation agriculture related lectures, and next after day probably on 27th we are having on some parts related to the agriculture soil physics related issues, then soil ecology and biology like this, and then there is a environmental based issues. The first day was started by the Professor S.K. Sanyal, ex-Vice Chancellor, Bidhan Chandra Krishi Vishwavidyalaya, also our respected teacher. So, sir, we will just wait for few minutes, I will say. Some of the students, they are trying to join, but they informed us that their connectivity is a little bit poor because they are staying in little bit remote areas. So we'll just take few minutes, sir. So in between, I will ask our head department and of course Dean Faculty Agriculture to briefly introduce Dr. Datta to the audience.
Good afternoon, sir. And
Good afternoon. Yeah,
Good
good
afternoon,
afternoon.
Good afternoon, all the participants and dignitaries, my colleagues, deans of the other faculties, director of research, and we are extremely privileged, sir, that you have given your kind consent to our lecture series that will be conducted from 5th of November to 11th of December 2020. And as already said, Professor Sina, that we have subdivided the lecture series in different segments, and you being the one of the doyen of your stream, we are extremely happy that you have given your consent, and basically the students will be very much benefited along with the faculties through your lectures. So just to start with the brief introduction of your CV, sir, whatever we have collected, Dr. Shiva Prasad Datta, he has done his PhD from Jawaharlal Nehru, BSc and MSc from Jawaharlal Nehru Krishi Vishwavidyalaya, consecutively from 1987 and 1990, and PhD from IIT Kharagpur during 1996. He has his postdoctoral program, University of Nottingham, UK, during 2003. He is a principal scientist and professor, Division of Soil Science and Agriculture Chemistry, IARI. He has mainly domain in the research areas on soil chemistry, soil fertility, and pollutions. He has got several awards. Subramaniam Award for Outstanding Teacher during 2016. Dr. B.C. Dev Memorial Award for Soil Physical Chemistry, ISCA. Jawaharlal Nehru Award for Outstanding Postgraduate Agriculture Research, ICAR. Best Teacher Award, ICAR, IARI. Commonwealth Fellowship, Dhiro Morarji Memorial Award, FI. Fellows of NAS. And we have also gone through the several papers of Professor Shiva Prasad Datta, and we are always in touch with his papers through our students, their research activity, etc. So we are very much keen to hear from you, sir, and I extend my sincere gratitude from our Department of Soil Science and Agriculture Chemistry, Uttar Banga Krishi Vishwavidyalaya, and hope that we will be in touch in near future also. So I request our convener. Okay, sir, you can start your lecture. Okay, thank you, sir.
So my slide is visible. Hello.
Yes, sir,
Visible?
visible, sir. Yes, sir.
Yes, it is visible, sir.
Okay.
Visible, sir.
Okay. At the outset, actually, I am really grateful to UKB for inviting me to share some of my experiences with faculty members and as well as students. Respected Professor Dibyendu, I think he's head and dean and head of the division, I think, Division of Soil Science, Agriculture, Chemistry, and Dr. Satara. He also belongs to the same alma mater from where I did my PhD, and other faculty members and students. So straight away, actually, I will start. Actually, I did not know actually what will be the exact topic actually on which actually I should speak. Then I contacted and then I decided, contacted you, and after discussion, I decided that I will talk on soil health, its importance and research priorities. Actually, I have prepare my lecture actually, keeping my eyes on student actually, mainly my young friend, my student friends. So here mainly I will cover actually your soil and philosophy, because we talk about our health, human health or animal health. So there also it is not soil. It is not that soil will actually provide the sustenance to our body. Historically, actually, soil is related to our philosophy, closely related rather, and our this religion and spirituality. So little bit I will touch that one also. Then importance of soil. Then I will try to link actually soil, human and plant and human health, because we are actually facing now very this is what should I say, very dangerous situation due to outbreak of this COVID-19. So here actually I will touch that aspect also. Being a soil scientist or being in agriculture, what we can do actually to combat this situation, if not immediately, in coming years. Then I will discuss soil health related constraints, because it would be not possible for me to cover all the constraints whatever we have. But I will try actually the most relevant and important the problems of soil to address, and to overcome those problems. What is the recent development actually? How research is going on? What should be the research priority to combat those problems? Now coming to your soil and philosophy, as I was talking about, here you see in India actually, in Indian perception, our native perception, we believe that our origin is from soil, and our final destination also will be soil, and origin of our life is from soil, and whatever we believe in as per Indian philosophy, that is also reflected in other actually say Greek philosophy. You see same thing is reflected. Then in Bibles also, in Quran also, in any book, spiritual book or religion book you take, everywhere the soil is regarded as one of the important component of our life or origin of life. So, but if you see the modern concept also, modern scientific concept, in 1951, for the first time actually Bernal, he actually put forward the theory that life is, or actually clay played very important role in origin of life because of the two facts. One is clay is having larger surface area, and it is layered actually structured. Interlayer space is there. So it is believed that clay actually provide surface area to react different organic actually organic molecules to adsorb on clay surface. And since clay is having actually this layer structure, it actually protect those organic molecules from ultraviolet light actually thousand years back when life was not there. And from there actually first the pinch of this protoplasm that was actually they believe Bernal created. So clay actually have very important role in providing the template for polymerization of organic molecule, from where actually this pinch of protoplasm created. Now, here if we try to link this, it is not that we are nowadays we are trying to link the soil health with plant health or human health, animal health. Long back actually, even in Vedas actually, soil actually has been considered as mother, and human beings as her son. That means human derive their sustenance from Mother Earth. And same thing is there in your Greek philosophy also, in Hippocrates time also, then in everywhere actually in ancient time, the soil health is important. They realized long back. But in modern time, in 1938, if you see the USDA yearbook of agriculture, 3 chapters were devoted to link or to describe the importance of soil health in human health, in maintaining the human health. And then in 1959, you see, the Voisin, he concluded that medical profession had largely ignored the soil in their efforts to improve the soil health, because that soil science should be the foundation of preventive medicine. Because actually our body is made up of, it is made up of mineral, and most of this mineral, almost all the mineral, we are deriving from the soil. In our medical science also, in treating, except antibiotic, now antibiotic also, majority of antibiotic are also coming from soil. So in treatment actually, if deficiency is there, we are actually provided with mineral. Again, those are coming from soil. Or to maintain our body, whatever mineral we require, almost all are coming from soil. So it is needless to say how important the soil health is, because now soil, this is very preliminary one. Just all we know from rock, actually through weathering and soil forming processes, soil is formed. The message I want to give here, you see why soil is so precious. Because we can, now we are talking about rocket science. Our science is so developed. We are talking about our transplant of these organs, different organs. So developed. We can prepare actually clay artificially. We can prepare sand. We can prepare silt. But we cannot prepare soil, because this is natural process. Through weathering, horizonation takes place actually. That requires this natural environment as well as your organic matter. So does it mean that if we prepare artificially sand, silt, clay and provide organic matter, then horizonation will take place in soil? No, it will not take place. It should be actually in that natural environment. So that means we cannot prepare soil. Soil particle we can prepare. So now if we see this, that's why actually soil is so important. And here you see how scarce soil is. To have an idea, you see the earth, that is the third actually this planet from sun, if you see. And this is the only astronomical object which can actually sustain this all form of life. And coming to the human, now we are about 7.7 million. So this earth only actually sustain or fulfill the nutritional and other requirement. Earth, that is, when I say earth along with biosphere, I am talking about. So, but if you see the volume of the soil, it is less than 1% of the mass of that earth. This is earth crust. Soil will be even less. So I want to say that how important the soil is, you see, and how scarce this and precious this material is, because all forms of life actually depends on this soil. And we should consider ourselves, particularly agriculturist and particularly soil scientist. We should consider ourselves very fortunate one, being a student of this soil science, because we are custodian of this precious soil, and we are trying to do it. We are trying to maintain or improving the health of this soil. So our job is so important. Then soil health definition, you all know, I am not telling, it is actually the capacity of soil to perform its function within boundary. Now, what are the function? Function is sustaining biological activity, diversity, productivity. Then this partitioning water and solid flow, purifying function. Then another is for storing and cycling of nutrients, providing support to socioeconomic structure. Out of this, I will mainly concentrate on storing and cycling nutrients. And this is our view of the soil science, as well as sustaining biological activity, diversity, and productivity. So now, coming to the human health, now it is, we are facing COVID actually. And if you see the 11 elements, actually all are coming from either atmosphere or from soil. And atmosphere is also due to earth only. Atmosphere is what a biosphere is there. Biosphere and atmosphere is there. Otherwise, if earth will not be there, then your atmosphere also will not be there. So 11 elements actually we are taking from soil and atmosphere, which constitute 99.9%. And other than this, another 18 elements approximately. So those actually constitute only 0.9%. Those include, apart from vitamin, those include some trace elements like zinc, iron, cobalt, copper, iodine, selenium, chromium, fluorine. So why I am telling this? I am telling this, there is actually these elements, out 17 elements are actually essential elements for plant also. But plant will not only take 17 elements, whatever is actually present in soil, those will be absorbed by the plants. And plant, we will consume plants, those will come to us, we will consume that. If we are non-vegetarian, then through your animal also, that also will come to our body, we can consume. That means we are totally directly or indirectly dependent on soil. Now, immune system, I will not take much time on this slide, only to tell you that this paper is published very recently actually. This is in 2020 actually, very relevant to our COVID era, where they actually conclusively proved that our immune system, to sustain and to keep our immune system effective, other than this vitamin A, D, C, E, B6 and B12, most important is zinc actually. Then iron, zinc, iron, selenium, magnesium and copper. So out of the zinc is most important, so is followed by its iron actually. And vitamin C, that is also important. So as such actually plant will not take vitamin from soil, but plant are autotrophs. They can prepare their vitamin, provided there will be adequate supply of nutrient to the plant. So plant is also directly or indirectly depend on this soil. Now, here. Now, so soil health is so important. And nowadays we are talking about the One Health, that is soil health, plant health and animal health and human health. So plant health, animal health and human health can be sustained and can be maintained by establishing proper linkage with soil. That means by soiling. Now one branch is also coming actually, that is known as geomedicine. For last many years it is there. So efforts are being made to maintain the soil health. Not only this is for immune system, zinc, iron, whatever I was talking about, but for maintaining animal and human health, whatever mineral is required. So that actually we should maintain in adequate amount in soil. So if we can maintain plant health properly or animal health properly, so the human health also can be maintained properly. So that is geomedicine. That means through maintaining soil health, health of animal and human, also how to maintain that. That branch is also coming. But after Green Revolution, actually, this during Green Revolution, our production increased, you know, but the this increase in fertilizer use, high yielding varieties, as well as irrigation facilities. There's some secondary problem also now we are facing, secondary problem of green revolution. So, and that lead to the deterioration of soil health, maybe physical degradation, that maybe your subsoil compaction, then your chemical degradation, that is nutrient mining, then imbalance use of fertilizer, then depletion in organic matter content in soil, low nutrient use efficiency, acidification, salinity, alkalinity, all we know, these all are self-explanatory. Then biological degradation, that is due to organic matter depletion. Another is actually pollution from municipal and industrial waste. So now I will talk this. I will actually further actually this try to understand the this problem actually, particularly the nutrient deficiency of nutrient, multi-nutrient or this single nutrient deficiency. If we see NPK fertility status of soil in our country, more than 90% of our districts either belong to low or medium classes. That means those are responsive soil. We need to apply the nutrient. Of course, in case of potassium, 50% of our district are belong to high category, and 50% situation is little bit better. In case of sulfur deficiency is 35%. In zinc, it is around 35% now, according to your recent assessment. Then boron also around 25 to 30% soil are deficient. So this deficiency, this problem of this deficiency actually further aggravated due to low use efficiency of nitrogen, phosphorus, and nitrogen and phosphorus, sulfur, and micronutrient. In case of micronutrient, it is abysmally low, 2 to 5% only. And if you see the global scenario, more or less same thing is reflected actually in world soil also. Then I was talking about zinc. Now you see in Southeast Asia, a large portion of our population is susceptible to this zinc deficiency due to inadequate supply of zinc. Then globally, again in Southeast Asia, if you see the deficiency of vitamin A and iron deficiency, iodine deficiency, this red font you see, substantial portion, a sizable portion of our population, those are actually suffering from this deficiency. So this actually, whatever deficiency we have in soil, that actually creeps to plant health and to human health as well. Now, how to manage that one? So that's what actually constitute our research priorities. So I will touch actually what we are doing actually, or other people recently in frontier area of research in soil science and frontier area of soil science, what progress are taking place and what to do to combat the problem as I have just I was explaining. So here I was talking about degradation of organic matter. In 1970, we conclusively proved that in our soil under this this tropical condition, organic matter content of the soil cannot be increased. What we can do, we can improve the quality of organic matter. But it is not that in our tropical condition, we will go on adding organic matter. And there will be matching or concomitant increase in organic matter content in soil. It will not be like that. It will actually, whatever is there after adding organic matter continuously, the equilibrium will be disturbed. new equilibrium will be established. How long that equilibrium will be there and elevated level of carbon will be there, that will depend on our supply and mineralogical, this makeup of soil as well as environmental condition. So now actually there is very important actually this one, the area of organic matter research. One is we should go on quality, how to improve the quality of organic matter. Very scarce information is there. And another is, yes, we need to determine the maximum carbon carrying capacity of soil, as we have determined, actually attempted to determine with Stewart model actually in major group of soil. We have 4 major group in our country: inceptisol, malisol, vertisol, and alfisol. So carbon carrying capacity is different. So this will help us actually to manage the organic matter carbon, organic carbon content in soil, as well as the quality of organic carbon. So maximum carbon carrying capacity and research. Another is, you see, we know, all we tell that organic carbon content should be increased. But what is the relationship of organic carbon content with yield? Because this organic carbon, plant is not taking organic carbon from, this is carbon from soil. Organic carbon actually, this is mainly related to physical condition of soil, maintaining the chemical environment of soil, maintaining the fertility. So, but we don't know what is the relation with yield. So here an attempt has been made, and we are working actually that how to determine the threshold value of this organic carbon. Say for in case of your alfisol, threshold is, limit is say 7.26 gram per kg, 0.72. To achieve actually 40% of relative yield. Beyond that, actually, we should not allow the alfisol to go beyond that, because this actually threshold value is determined depending on the long-term experimental data. And similarly, you see upper threshold where 80% relative yield is achievable, that is 0.84. So this data, why I am telling that, to tell you in different actually threshold value of this organic carbon is different in different soil. That need to be actually worked out. Another is actually in IRI or in agriculture research institutes. We are very weak actually in fertilizer product research. So to enhance the use efficiency of this applied nutrient, so in case of nitrogen, it is 30-35%. So with phosphorus 20%, micronutrient 2%. So new fertilizers product we need to develop. So here we are working on nanoclay polymer based actually slow release fertilizer, polymer coated fertilizer, where actually we are trying to reduce the solubility of this fertilizer. Because why actually use efficiency of nitrogen is low? It is due to different losses. In case of phosphorus, why use efficiency is low? Because of fixation. In case of micronutrient also fixation, because depending upon the affinity of different soil constituent, it is actually fixed in soil. Yes, it is fixed in soil. So by developing this product, either nanoclay polymer based or your polymer coated or natural polymer coated, this material we are developing, and we are trying to synchronize the release of nutrient from fertilizer and synchronize with demand of plant, so that use efficiency would be increased. So in case of micronutrient, we could increase in case of zinc and boron by 5 times. In case of nitrogen also 25 times. We are able to curtail the fertilizer dose by 25%. And in case of phosphorus up to 50%, the application can be curtailed. Now you see, I was talking about phosphorus. This is acid soil. Purposefully I have taken because your university is in acid soil. Just hello, सर मैं वो लेक्चर दे रहा हूँ सर, अभी बात करता हूँ सर. हाँ सर. so here you see the phosphorus. So whatever phosphorus, 20% use efficiency, year after year we are using. So then where phosphorus is going, phosphorus is fixed in soil. So this is not only phosphorus build-up, this will lead to the economic loss. And at the same time, your micronutrient, metallic micronutrient deficiency also will incur due to build-up of this phosphorus. So several options are there. One, this is, I need not to elaborate, that phosphorus solubilizing fungi, phosphorus solubilizing bacteria we can use. And where we see that substantial amount of actually phosphatic application of phosphatic fertilizer can be curtailed. And where if you see the chemistry, the application of this microorganism actually mobilize the phosphorus from relatively non-labile pool to labile pool, hence solubility increase, availability increase, that is reflected in plant content also. Then this is also same thing. Phosphatic this is curtailing of dose of phosphorus with using microorganism. And another is, I don't know how many of student I am asking, how many of you have seen the Russell book, that this is soil condition and plant growth. There is one table, very old book, you go through that. What they proved actually in Ratham experimental station, for 100 years, they did not apply phosphatic fertilizer. Instead of that, they use silica, because the chemistry of silica and phosphorus is very much same, orthophosphate and silicic acid, because solubility of both is controlled by adsorption and desorption in sesquic oxide and clay mineral. So they could conclusively prove the 100 years they did not supply actually phosphatic fertilizer, one of the treatment, but silica they supply, which could maintain actually yield and availability phosphorus up to 100 years as good as where they supply this phosphatic fertilizer. So taking the clue from this, we have initiated the work actually. That also we can reduce the dose of phosphorus, and that will decrease the fixation of phosphorus. So these are the some of the area one should work actually to enhance the use efficiency of phosphorus. Another, this is very important and very important aspect actually I am going to tell here. You see, if you see the uptake of nitrogen and potassium, both are almost same. But when it comes to the application, you see 65 to 70% of our fertilizer consumption is constituted by nitrogenous fertilizer, and another 70, another maybe 25% phosphates. And in case of potassic fertilizer, it may be less than 10%. You see, so even if uptake is similar to nitrogen, we are not applying potassium. So what is happening actually? That actually leading to depletion of potassium from non-exchangeable pool. Due to that, the interlayer potassium is coming out, and there is distortion of clay mineral. So soil health is deteriorated. This is irreversible loss. So we need to apply actually, even if crop is not responding to application of potassium, because in some of our soil is adequately supplied with potassium from plant nutrition point of view, but from soil health point of view, even this potassium is even more important from soil health point of view, maintenance of soil health. So, and here our study shows that you see in long-term experiment, everywhere there is negative balance, and which lead to, you see this X-ray diffraction, where actually elite is deteriorated 50 years. This is due to not use of potassium for 50 years actually. The elite is converted to actually this kaolinite actually. So there is reduction in elite content, increase in kaolinite content. So this is very dangerous, and because surface area is increased, so not only soil health deterioration is there, but now whatever fertilizer we are applying, say we are applying 150 kg nitrogen, or even say 60 kg phosphorus, if this will be deteriorated, surface area will increase, it may require double to triple amount of that this one. But this process is very slow. We need not to worry about. It is very slow process, but we should give proper attention to it. Otherwise, maybe it requires 1,000 years, lakh years, million years. All our soil will be converted to altisol due to over exploitation of phosphorus. And you know, altisol productivity of altisol is very poor. What to do? We need to decide the maintenance dose. We need to decide the maintenance dose, how much we need to apply. So we initiated the research on that. And you see, we have chosen actually two soil. One is low K and another is high K, where you find both the soil, when we apply 50% recommended dose, after that actually response is not there. And here you see based on crop response, we cannot decide the maintenance dose. Uptake also we computed, because this is actually exhaustive cropping Sudan grass we are taking. Now it is after 5 cycles, it is continuously we are taking. So here also you see the depletion is there. If based on the uptake, from where the plant Sudan grass is taking potassium in low K soil, also from this soil, high K also major contribution is from soil. This is due to luxury consumption. Actually, we cannot differentiate low K and high K soil. Then now we are trying, actually, we studied the quantity and intensity parameter, non-exchangeable potassium. Yes, it is there in low K soil. You see, wherever when 50% potash we are applying, there is minimum actually depletion in non-exchangeable K. This parameter is very important. We should concentrate on this. And in high K soil, we are still experimenting, and we have not found any parameter which will be indicator of this sustainable management of potassium in soil. So maybe because this is very high K soil, further when it will be depleted in some point of time, we will be able to know what parameter is important. So whatever we are doing, that is not important. What is important is we should put effort, we should initiate research to work out the maintenance dose of potassium to sustain the soil health. And another is this is conservation agriculture. I am not only thing I want to tell, in conservation agriculture, you see where hello. Hello.
Sir, we are listening. Might be there are some interruptions from the network.
No. No, how much time I have?
Sir, 15 to 20 minutes, sir.
20 minutes. Okay. Now it is so 340. Okay. 340. Okay. So here you see in conservation agriculture, actually residue retention is one of the principles of conservation agriculture. Just I am touching actually here, and we know the residue of cereal crop, it is very rich in potassium. So you see wherever actually in conservation agriculture residue is retained, del G, that is free energy of phosphorus, that is actually increased. That means the phosphorus is loosely held. Where it will be loosely held? It will be loosely held in other fraction other than your non-exchangeable potassium. Non-exchangeable potassium is very tightly held. So that means addition of crop residue actually increase and improve the K supplying capacity of the soil. This is one of the option actually where actually we can using the residue to great extent we can actually manage the potassium. This is K depletion. Then this is also same thing. Now another is we are talking about balance application, because to sustain the your soil health and human health, balance application is required. Just I am touching. So we have developed this under the leadership of Dr. Samarchand Datta, SC Datta. He is retired now. developed this STFR meter. So using this, actually, we are advising the farmer to go for balanced application of fertilizer. That will actually increase the return, farmers' return, decrease the input cost. So similar kind of actually instrument or improvement of this instrument should be attempted in all places to enhance the balanced application of nutrient, increase the farm. Another area I will touch, that is nanotechnology and use of nanomaterial actually in agriculture. Now a lot of research people are doing actually, but my experience actually, we have conducted two type of nano. Actually, when I say the nano-based polymer composite, nano clay polymer composite based fertilizer, there we are not using any nanomaterial. We are actually, as a vehicle, we develop nano clay polymer composite. Nano size clay we use actually bentonite. But there we are loading the nanoclay polymer composite with say zinc, in case of zinc, zinc sulfate, in case of iron, iron sulfate, in case of phosphorus, DAP. We are not using any nanomaterial, but I am talking about nanomaterial. Say zinc oxide nanomaterial, iron oxide. So lot of literature is there. You see, I actually try to actually review. I have reviewed and collected the information where all sort of information is there. Some say there is positive response, some say negative response, and all sort of nanomaterial as a fertilizer material people are using. But our experience is when we use this, we have synthesized also the zinc oxide and this iron oxide nanomaterial, but response of crop is very poor, not even negligible actually. We have taken wheat crop, but crop did not respond to application of this. Soil application of this one, and even foliar application also. But here now coming to this, all sort of actually this negative positive reports are there. But now need is, this is not enough. And I am not going to this controversy also whether it is working or not. Literature I have presented. But our efforts should be actually, research should be initiated more than positive response or beyond the positive or negative responses to find out the mechanism, how this nano is working. Say nano size, that is less than 100 nanometer, any particle, one of the dimensions should be less than 100 nanometer. Now, what is the dimension of zinc? So zinc nanomaterial we are using, zinc divalent zinc ion, what we are supplying through zinc sulfate. What is the size? Size is 0.65. This is Armstrong. Armstrong means 10 to the power 10 dimension. I am talking meter, and nanometer is 10 to the power 9 meter. That means our ion size is far less than your nanomaterial. So even if we go by size, why should be this nanomaterial should be more effective than this ion? This is one question we have to address, and we have to prove actually this one. Another is, if you see the solubility of zinc oxide, iron oxide, solubility is very poor. We know whatever is, even if it is going inside to the plant, and evidence I am are there that it ruptured the cell and may enter into the root. But unless and until it is converted into ionic form, it cannot take part in metabolic activity. Why there should be positive effect of this one? I am not talking against this nano particle use of this. This is how actually this development take place. I am telling only to initiate the research in that direction, to give answer of some of this question in nano area, in nano application in agriculture. Then even another is say here in nanomaterial people are using nano gypsum. This is understandable. Yes, nano gypsum people are making the gypsum nano size, surface area increase, reactivity increase. So this is one of the option. But again, we need to work out the application actually, because nanomaterial application is dry application of this gypsum. This will be very difficult. It will go through, enter into our body through nose. Then there will be problem. So how to apply, that has to be worked out. Another is in acid soil, that your universities in where the acid soil is there. So here nowadays the in liming actually only 1/10 of lime people are using, and people are standardizing the frequency also. So here also we should carry out the research, and we should take the detailed study on the chemistry of lime in soil, how actually it affects the availability of different nutrients in soil, mobility of nutrient in soil. That type of information is not available. That actually you should generate. Another is, you see, as I was talking about soil health. Human health is reflection of soil health. Animal health is reflection of soil health. So to prove that, now it is very difficult to prove, because nowadays food is actually produced somewhere, consumed somewhere else. So to get the positive relation, it is very difficult. But we have collected data from Mandla and Betul district, tribal area, where actually they are dependent on local produce. So there is actually, you see, positive relation between the zinc content in human blood serum and zinc content in grain of maize, grain of rice, and grain of wheat. Then similar is here actually in Rangareddy and East Godavari districts also. They found positive correlation between deficiency of zinc in human and deficiency of zinc in soil, deficiency of zinc in plant. That means there is link. Now, two element actually I was talking about, that is your zinc and iron from human health point of view, zinc and iron. So here, in case of zinc, actually you see, and iron both, our staple food says cereal, wheat. It is easy to actually enhance the biofortification, agronomic biofortification of wheat, but and other crop, pigeon pea. But in case of rice, actually it is very difficult. Whatever zinc or iron we apply, that mainly accumulated on rice husk actually. So in grain endosperm, in white rice, it is very difficult to enhance the content of iron or zinc. So that in collaboration with actually our geneticist friend, soil scientist, in collaboration, they should work out and develop the suitable variety, and combined approach we should follow, agronomic and genetic biofortification, to alleviate the deficiency of zinc and iron. Then this is actually data where they have shown that soil and foliar application combinedly is the most effective to enhance the zinc in wheat. But here, this is very important study actually. You see, simultaneous biofortification of wheat with zinc, iodine, selenium, and iron through foliar treatment of micronutrient in 6 countries in 27 locations. Very large experiment they conducted, covering China, India, Mexico, Pakistan, and South Africa. And they are successful actually in enhancing zinc, iron, and your iodine content in different food, actually, this edible portion of the crop. Then you see, this is also important study. If you want, I can send my presentation for the student. I will send, and your teacher, I request actually the professor Dibyenduji to distribute this one actually among the student, my presentation. I will send actually through email actually. So this, because it is not possible for me to explain everything, lot of data are there, so that will be useful. So here you see, in China actually they proved these are the actually northeast rice, centralist rice growing region, southeast rice growing region. So these are actually 4 major regions in China. So they conclusively proved that if they fortify the rice with zinc and iron, they can reduce the medical burden actually of the state, of the country actually, to different extent actually, because otherwise due to the zinc deficiency, iron deficiency, we different disorder we face. So there is lot of actually expenses incur actually to combat this situation. Then this is very important actually, successful success story of biofortification of selenium. You see, we do not have actually selenium problem much in our country, but in Finland in 70s actually selenium problem is such that in cabinet parliament they actually forced to decide that whatever fertilizer they will sell, all fertilizer should contain selenium. So they add selenium to fertilizer, and they actually could enhance the selenium content in soil. That actually transported to their different food crops, and now selenium deficiency is controlled. Lot of actually medical expenses burden is reduced actually. This is success story in your Finland actually. Another success story you also know. Then few minutes I will talk actually in my area actually. Mainly I work with actually this major share of my work is with actually risk assessment and remediation of polluted soil. Another 10 minutes I have, so I will devote time on that area. But before that, you see another successful this biofortification is not biofortification, alleviation of deficiency, that is iodine deficiency through what? Through iodized salt. In 1950s actually, USA they have gone for we have gone for iodized salt much before USA they have gone for. So in our country, this is also success story. That is not biofortification of our food material. We soil scientists do not have any actually rule also, but I am telling you as an example, the fortification of your salt and with iodine alleviate the deficiency of iodine in our country to get extent. Other country also, we all know that. Now coming to this risk assessment and remediation of your polluted soil, here we know actually in over 137 million people and more than 17 countries, they are actually suffering from arsenic toxicity. And severe problem is our West Bengal and our this Bangladesh, we have severe problem. And any metal or metalloid problem we have in our country, that is actually geogenic in nature, that is arsenic. Then we have selenium toxicity, that is also in limited area in Punjab, actually in saliniferous soil. Mostly your animals are affected. Then chromium, wherever leather industries are there, we have chromium problem. Zinc, cadmium, nickel, lead problem, where we have? We have in industrial area, mining area, smelting area, there we have problem. So this we all know. But I will actually concentrate on now how to actually assess the risks of this polluted or contaminated soil. That means where we need to initiate the research. One is on risk assessment, because first we need to know how to what extent our soil is polluted, whether we need to actually go for remediation or not. So to do that, we need to know the critical limit of this metal or metalloid in soil. So here actually we do not have in our country as such. Whatever we follow, limit we are following, that is mainly we are following of Great Britain, that is UK we follow. But in different country actually, as I have given in this table, this critical limit, this is based on total metal content actually. They use as a simplest this indicator of metal hazard in soil in different country. And their legislature also, these limits are there actually. If anybody grow crop in soil, agriculture soil, which is having more than this total metal or metalloid content, that is punishable actually. That is not allowed in different country. But in India, we do not have any system like this. But the point I want to tell you, even this is not sufficient, because as we know, being a student of soil science, the total metal content does not indicate its availability. In fact, availability of metal is actually controlled by the other soil constituents, say pH, what is the clay, what is the sand content, what is the organic matter content, which crop we are going to grow. So based on all these things, actually, the level of toxicity should be decided. And level of toxicity of metal should be based on soluble metal. So that's across the globe, not only in India. We do not have any toxicity limit of metal in relation to human health, which is based on extractable metal or soluble metal. So we should carry out work in this direction. Another, I am coming to that, what type of research actually we should initiate. But before that, you see, another different this critical limit or permissible limit we use actually in our country, borrowed from other country. Those are mainly based on actually content in food material. So in my opinion, these also such type of limit as given by Codex or other agency, European Union, those are also not much more meaningful. Why? Say for example, in West Bengal, we use actually all over globe, the critical limit, this permissible limit of arsenic is 200 ppb for rice. For white rice, it is 200 ppb. Now, in West Bengal, a person take 500 gram rice per day, 400 gram rice per day, or even those who are in urban area, those who are living and those who actually are not actually putting much labor, actually physical labor, they may take 200 gram. So this critical limit also should vary from person to person. If you go to Punjab, they take 50 gram rice, 100 gram rice. So same critical limit, same permissible limit, how it will be applicable? Because we do not have luxury of actually agricultural land, and we should not put very stringent critical limit so that some of our agricultural land would go out of cultivation. Or at the same time, critical limit should or permissible limit should not be so loose that it will not be able to protect human life or animal life. So what to do? We are working for last maybe 10-15 years actually on this model, where actually what we are doing, we are integrating soil chemistry, agronomy, and human health together. How? Actually, in soil chemistry part, if we know the metal, extractable metal content in soil, and few important parameters like pH or organic carbon content in soil, so we can predict the solubility using solubility models. Several models are available. We have actually constructed. So then we know how much actually metal will be soluble. That means what is the intensity of metal, what is the activity of metal in solution. We know the quantity as well as intensity. Then through modeling approach, free ion activity or other model, we can predict how much will go to the food material, rice, wheat, or any other. Then through food material, how much is going inside. That also we can compute. So, and this US EPA, that is United States Environmental Protection Agency, from time to time, they actually prescribe the permissible limit of maximum intake of metal and metalloid, permissible limit of intake of metal and metalloid by human. Say for example, cadmium, 0.001 milligram per kg of body weight per day. One can take from all sources of food, drinking water. Beyond that, if people will take, then there will be toxic effect. In case of arsenic, say 0.021 milligram per kg of body weight per day, like this. So we can integrate with that, and through back calculation, we can prescribe if what soil pH, what is the at what level of soil pH, what level of organic matter, what should be the extractable limit of extractable metal in soil. You see here, say in case of rice, this is actually we predicted actually how much is the maximum intake in terms of hazard quotient. Hazard quotient is the ratio of intake of metal through food material and intake of metal, permissible intake of metal. So that should be less than 1. But here only when we compare one food material only, we cannot survive only on rice. So from other food material also, some of this arsenic will come, drinking water come. So this hazard quotient we should rationalize whether we will allow up to 0.5 or 0.25, 0.75, that is ours. But the point I want to tell you, just see pH is 7.5, organic carbon is 0.5%. Then up to 0.43 ppm arsenic we can allow in soil. But when you see your pH is 8.5, organic carbon 0.75, then up to 0.54. Like this, lot of variation in spinach, cadmium, and here in wheat, cadmium content. You see, in case of wheat, pH is 6, organic carbon is 0.5. The permissible limit of extractable cadmium, that is DTP extractable cadmium, should be 0.27. And if pH or organic carbon is pH is 8, organic carbon is 0.5%, then we can go up to 1.31. That means this is soil specific critical limit. So this type of research we should initiate and we should prescribe. This is one. Then we could identify actually in phytoremediation. We could identify different species, hyperaccumulator. But the package we need to develop, how frequently we use in particular situation, how many times we will use, then the metal level of our soil will come down and we can grow other crop for phytoremediation. Those type of package actually we should work out. Then you see main difficulty in phytoremediation is solubility of metal. So the phytoremediation takes longer time. So in European country, they actually use different chelating agents, synthetic chelating agent. They to solubilize the metal to enhance the efficacy of phytoremediation. What happened? Now they realize after 2 decades that their groundwater is being polluted because due to metal actually, which is leached down due to use of EDTA or DTPA. So in this direction also we should initiate the research where we should use actually some of our solubilizing bacteria or some of our natural manure, say green manure. So instead of using EDTA, DTPA, so efficacy of phytoremediation extraction can be enhanced and used for remediation. Then another, this is actually recently one of my students did, where actually we used in collaboration with BCKB, Somnath, Dr. Somnath Bhattacharya, I think Bantopadhyay Bhattacharya. So in collaboration with him, actually, we evaluated some of the variety, local variety, where we found that this soil is having actually around 20 ppm, 39 ppm actually your this arsenic. So Nadia district we have collected. So here you see the variety Batsabhog, local variety of West Bengal. In that soil also, what Batsabhog produced the rice, which is having actually arsenic content within permissible limit. So these Batsabhog, such type of variety can be used as a breeding material by geneticists to transfer this gene to this one. And we have seen also application of silica also, because the rice plant use same transporter for transporting arsenic as well as silica. So when you use the silica, that also reduce the transportation, absorption and transportation of arsenic. So this type of research actually should initiate, where it indicates integrated use of this genetics approach and our soil science, the soil manipulation, soil chemistry manipulation, this reduce this problem to great extent. Then another, I think this is last, I think I will not, I have consumed all my time, 1 or 2 minutes more I will take. So this is another area, very important and interesting area. You see, when we go for actually remediation or remediation of metal or metalloid, we actually as a soil scientist, we should study, we should identify in soil what are the solid phases, what are the mineral, which actually govern the solubility of metal. So earlier actually this determination of intensity of metal or metalloid ion in solution, this is also very difficult. But now Becker soil test of this USD actually, I have used actually, they develop for different purpose. I have used actually to this determine the activity of metal and metalloid in soil solution. So that is very easy. So that way we can identify which is the solid phase. For example, in actually Rajasthan, this smelter contaminated soil, there is lot of actually cadmium pollution is there. Village after village, people fled away actually due to this pollution. So very large area. Now case is in Supreme Court actually. They farmers and other people, they went to Supreme Court. So now the point I want to tell, when you identify the solid phase, you see octavate, calcium carbonate, with solubility line we actually can draw. And here actually this soil particularly, which is intensively contaminated soil, the solubility of this cadmium in this soil governed by this octavate. Taking the clue, this soil we apply actually lime. Here you see we apply lime actually, and lime application of lime, even soil is not acidic in nature, very helpful in enhancing the formation of your octavate. So which actually reduce the activity of cadmium in solution, transfer of cadmium, and this will actually help in remediation of polluted soil. Another is generalized, you see, as a rule, as a actually this different material actually organic amendments people use, list I have given, and they reported that for some metalloids or other, these are effective actually. So I think this is all. I think so now again I will repeat for my student friend. Now you see the very survival of this mankind depends on this uppermost few inches of this earth, and we are very fortunate. Some people may be actually, I have seen in my during my student life also, some people they have actually great regret. They could not go to medical profession. Ultimately, they come to agriculture actually, and they could not get. But I say, you don't. There is no point of repenting. Medical people, they have done they have proved their utility to the society. Now it is our turn. Actually, being we are very fortunate actually to be in this profession, and that too particularly in the soil science, because now by proper maintaining actually this soil health, we need to establish how to maintain the plant health and human health. Even more than medical profession, if we want, we can be more useful to the society. So there is no point of repenting. We are actually in very doing very important work, and we should be proud of that. Another is few slide actually I did not include because I know even 1 hour will not be sufficient. I cut actually. Another point I want to tell my student friend, you see our basic and applied research, both are actually just like our 2 legs. With 1 leg, we cannot walk actually. So the student, those who are, and all people, if they try, they cannot carry out basic research. Either they do not have temperament, or they do not have facility, or they do not have adequate support from top. So wherever you get adequate support, you have temperament, and you have inclination. So one should go for basic research, and because it is very difficult to carry out the basic research, of course, keeping an eye on its application. We should know, we should be very clear what for we are carrying out research and where it will be applicable. So that is very important. And I have taken even whatever time you allocated. I am sorry for that. I will stop here. And I am so much grateful and to the Professor Dibyendu Chatterjee, I think, and his team and students and BCKB as such Vice Chancellor of your, sorry, not BCKB, Uttar Bang Krishi Vishwavidyalaya, Vice Chancellor also, he was here actually earlier, Dr. Chatterjee, who are actually very good friend. And so I am very grateful for inviting me to share some of my experiences particularly with the students, because I have not told, I believe, anything new to the faculty or your teachers, but at least those are students actually. I have shared, and it is highly satisfying for me to share some of my whatever little experience I have to share with the students. That's all. Thank you. Thank you very much. Thank you.
Thank you very much, sir. Thank you for your very elaborative lecture and deliberation. I think the students will be benefited listening to you in this lecture, and we have also been benefited. We have learned a lot of things from your lecture, especially for the dental pollutions as well as the different aspects of soil health. So I will ask the students to ask some questions. Students, please ask some questions to sir. Students, please ask the queries whichever you have in your mind to share. It is your opportunity to listen Professor S.P. Datta today. The students. Okay. Okay.
If not anybody, may I just comment? Myself, Dr. Satra from Kajri, Jodhpur.
Yeah. Okay. Okay. Dr. Satra, you please.
Yes, actually, I am listening this lecture because I have also actually attended classes during my student life of Dr. S.P. Datta sir, specifically on foreign languages during the year 2001 or 2, I think. So I forcefully kept myself busy to listen the lecture, and it is a wonderful thing that I have heard from his that research at the Division of Soil Science in IIRA New Delhi. Although I have gone through several times of his different students' research, I think one thing I just want to mention, whatever Dr. S.P. Datta sir has said during the last of his presentation regarding the contribution in the society by the students from agriculture community and the researcher from agriculture community, and it is no less than the medical profession, whatever he has told me. I fully agree with Dr. S.P. Datta sir. And the students sometimes actually sometimes is not so much motivated from our society that agriculture students are not doing the good profession. It is not comparable with the profession in medical science or in engineering science. But I also luckily or unluckily came to agriculture profession in the BCKB in the year 1994 after not getting an admission in joint entrance exam. So actually I was selected in some other colleges so far away, so I didn't go there. But at the later stage, I realized that it was the actually the fortunate thing in my life that I entered in the agriculture profession. And so many days have been gone in agriculture research, and I am so much thankful to God that I got the opportunity to work in the agriculture field and to serve the society. And this lesson actually should be gone through the every students of agriculture science in India. and we are not less than any profession. Starting from ISRO, people are working there. We are in continuous touch with them also. We are also continuous touch with people from IIT background also. And we know now the importance of agriculture science in India. And specifically the soil scientist part, the contribution in society, it is enormous. We cannot think about that whatever Dr. S.P. Datta sir was telling, that pollution-free soil and giving the food in the mouth of 1 million people in India, it is not a joking. So that thing we are contributing in the society. So I request all the students, friend, that you first inculcate these things in your mind whenever you will do the research, because you are contributing to a great thing in the country. So this message I again tell you in the students' friend. So thank you, Dr. S.P. Datta sir, again reminding the same thing.
Thank you, Dr. Satara. Actually, Priyabrata, I should say.
Yes, sir.
And he was actually one of our very bright student here, actually. And I wish you all success in your research career, research endeavor. And I expect, or I wish that you should contribute much more in coming years in the field of agriculture, particularly in soil science, and for well-being of the people of our country. Thank you.
Thank you, sir. Dr. Dibyetu sir, you can conclude now, sir.
Hello.
Hello, Dr. Abhas Sinha. Hello.
Hello, Priyabrata.
Yes, yes.
Actually, what happened? We are on a hotline, so we didn't have the backup. So actually, the power cut happened here. So it
Okay.
is ready there. So just everything got messed up.
Okay, okay. So actually, I commented something in during this breakup period. Anyway, I have already done this thing. We can conclude now.
Yeah, we are just waiting for the participant to come. Actually, I can find.
All participants were there. Ask a question. Question are there.
I mean, concluding.
Sir, you can stop share. Yes, sir.
Hello, sir. Are you there? Hello, Professor Datta. Sir, are
Hello.
you there?
Yes, yes, yes.
Okay, okay. Sir is there. So, any other question from faculty? Please.
Hello.
Hello.
Sir, myself, Dr. Dipan Mukhopadhyay. Just not just a question, sir, just to hear from you. So it has been observed that particularly for the metal and the metalloid, there is a transport from the soil to the plants, its roots to shoots, and ultimately to the economic produce. And that economic produce is being consumed by us, and we are being intoxicated with that particular metals. So, is there anything to find out whether the initial restriction of the entry of the particular metals to the root that may be able to not to arrest that particular metal in a particular location? So is there any mechanism or any technology that has been going on, or the research or you are doing there in IRI or in other provinces?
Yes, very important issue you raised. Actually, here, this to reduce the transfer of metal, actually, first of all, I should tell you that there is no actually 100% effective methodology so far to check the transfer of metalloid from soil to plant. And that's why actually first and foremost important this strategy should be we should try to keep as clean as possible our agricultural soil. Second, if there is elevated level of metal due to use of sewage, sludge, industrial effluent, or from any sources, then to reduce the transfer, one is we can reduce the solubility of metal in soil itself using different amendments. Say in acid soil, lime will be very effective, but we need to decide how frequently we go for lime application. Another is, say, metal and metalloids, say cadmium pollution is there. So application of zinc in very high dose. Example I am giving, this will actually check the entry of cadmium to plant. Then one example I have given, if we apply say silica, it will to great extent it will reduce the entry of arsenic. If you apply sulfate, it will reduce the entry of selenium. So this is as far as actually translocation, absorption and translocation of metal or metalloid in plant. Another is phytoremediation technique I have explained, that is to reduce the metal or metalloid content in soil. But this technique is very slow actually. It may take several years actually because of low solubility of metal in soil. Once actually metal or metalloid get into the plowed layer, it is very difficult to remove. Hello.
Thank you, sir. Thank you very much.
Another approach actually, geneticist. Some people are doing now in collaboration. One I have presented that if we can identify the cultivars actually of different crop, which is actually which actually exclude the absorption of metal and metalloid. So that will be also very good, but it is difficult actually. It is difficult.
So to identify that particular
variety and breeding also, that is also time taking, but that is actually ultimate solution. That will be the ultimate solution.
Thank you, sir. Thank you very much, sir.
Okay, any other question from faculties? No. So, Dr. Sobhik Dev, please come here and share your vote of thanks and summarize the lecture today.
Hello. So I am fortunate enough to summarize your lecture. Myself, Sobhik Dev. It was a very elaborative lecture sharing the different domains of soil science, and it was, I think, very helpful. It will be very helpful for our PG and PhD students and also for our faculties. So, in a nutshell, so your total talk was based on few points like the soil and philosophy, the importance of soil, linking soil with plant and human health, soil health related constraints, and the final one is recent development and research priorities. So in soil and philosophy, you said about the ancient philosophies about the soils, and also you mentioned how the modern sciences like USDA and other scientists have acknowledged the same over the years. So how life is related to the soils and how life on earth thrives on soil. The function of soils, you have discussed that in very brief, and how they are source of all the human element, all the human nutrients. And then, sir, you very elaborately describe us the physical degradation of soil, chemical degradation of soil, and the nutrient deficiencies in Indian soils and South Asian soils like zinc, sulfur, boron, etc., and the issues related to that. Then, sir, you move to the research priorities, which should be our research priority, that is degradation of soil organic matter, and the need to determine the carbon, determine or understand the carbon carrying capacity of each soil. That was a very new concept to me, especially. Then critical carbon input required to reach carbon threshold value for that soil. And then you, sir, describe the possibility of use of nanoparticles, nanoclay polymers, and also the microbial interventions to solubilize soil carbon. You describe as the possibilities of, potassium dynamics, and how these dynamics can be controlled through conservation agriculture. Sir, you discuss about the Kusha STFR meter, so that we can decipher our knowledge to the farmer's doorstep. And then you describe about the importance of different micronutrients, for example, impact, and how different countries like Finland and India and other different countries are dealing with that. In the final slides, you described about your recent researches on soil pollution, metal and metallite pollution, arsenic pollution in Bangladesh and West Bengal, selenium pollution in Punjab, chromium, zinc, nickel pollution, lead pollution in different parts of the country related to urban, mining, and industrial activities. And then, so you suggested the prediction of the metal uptake by FIAM model. I'm not elaborating in a lot. So you said about the soil specific permissible limit. It is a very good concept. So I think the phytoremediation, option to use green manure, and selection of varieties. And finally, you said that identify the role. We should identify the role of us, the soil scientists, for the societies in the society. So it was a great lecture for us. So we are greatly, we got a lot of knowledge from your lecture. And sir, please share your slides with us. For the vote of thanks, I would like to thank our Vice Chancellor for facilitating this arrangement for this departmental webinar. I like to thank, on behalf of our department, to all the deans of this university: Dean Faculty of Agriculture, Dean PG Studies, Dean Horticulture, Dean Technology, Dean Students Welfare, Director of Extension Education, Director of Research. I also like to thank all the teachers and scientists who was there today and is there today with us to deliver their lecture and gave their precious time, and all the lectures which happened in the last day and which will happen in the next days. The coordinator of this total thing or total initiative, Dr. Dibyendu Mukhopadhyay, who is also the HOD and also the Dean of our faculty, the convener, Professor Avas Kumar Sinha, joint convener, Dr. G.C. Bonik, members, Dr. Amrit Tamang, Dr. Shovik Dek, Dr. Kapudip Kormokar, Dr. Hriday Kamal Tarafdar, and Dr. Tapush Pandit, all the students and all the attendees. And I would like to thank Pankaj, who arranged and who helped to arrange all these things. And I am now handling the mic to our coordinator, Professor Dibyendu Mukhopadhyay. Sir.
Okay, sir. Thank you, sir, for your nice deliberations and your kind presence. So now you conclude the session, and we'll be in touch with you in near future, sir. Thank you very much. Thank you all.
Okay, thank you very much. In conclusion, only I say that, particularly for the student, please, whatever you will do, you do sincerely, and whatever point I mentioned for your particularly for choosing the area of your research, that also should be helpful to you. And third point is, whenever you will take research, you try to keep proper balance between basic and applied research. Thank you very much. And I am more than happy and really grateful to Professor Dibendu Mukhopadhyay and his team, and to all of you for giving me opportunity to share some of my experience, whatever I have with all of you. That's all. Thank you very much. Thank you.
Thank you.